So our molecular equation and our formula equation, all the substances in the chemical equation are written out using their complete formula as if they were molecules. It's going to give the overall reaction stoichiometry, but not necessarily the actual forms of the reactants and the products in solution. So here we've got lead nitrate reacting with 2 potassium iodides to form potassium nitrate and a precipitate, lead iodide. Right? And so here we've got this AQ, and this guy's an AQ, and this guy's an AQ. And if you've done chemistry enough, you know that they're going to be soluble. Right? Our strong electrolytes are going to be soluble. And if they're showing up as a reactant over here and it says AQ, it's a good chance that they're going to be completely dissociated. And then over here, KNO3, or nitrate, right? All nitrates are soluble. So this guy is going to exist as K plus, 2K pluses, and 2 NO3 minuses in solution. So this molecular formula is a little bit easier to balance and get the stoichiometry right. We've got to go an extra thinking step to figure out what's happening with our ions. Our ionic equation explicitly writes that out. So all of our strong electrolytes are written out as ions. So rather than taking PbNO3AQ, we will write it as Pb2 plus 2 NO3 minuses. And our 2Ki AQs become 2K pluses and 2I minuses. And that's going to form 2K pluses and 2 NO3 minuses. And rather than write that out as KNO3 aqueous, we're going to show that as individual ions. Now our lead iodide, because it is a solid, does not break up into its component ions. So we're going to leave it as is in our ionic equation. Right? In that equation that we just saw, right, we noticed that there were some things that are unchanged on the left-hand side and on the right-hand side. So our nitrates and our potassiums are unchanged on both sides of the equation, right? There's no change to these guys, right? It was NO3 minus aqueous, and over here it's NO3 minus aqueous. So it's minus, nothing has happened. It hasn't recombined to form a new substance or a precipitate, right? And those guys are spectator ions, right? They're just hanging around. They're not participating in the actual chemical reaction that happens. When we remove these spectator ions, we're going to end up with a net ionic equation, right? So no spectator ions. So he's a tater wearing some spectacles. So he's a spectator ion. Right? So only the ions undergoing a change are shown. So our net ionic equation, that's the business end. That's what's chemically the most interesting part, is that our lead 2 plus reacts with 2 iodides to form lead iodide solid. So let's do a quick practice. We're going to write out the formula equation, the complete ionic equation, and the net ionic equation for the following reaction, which we have expressed in words. Aqueous potassium chloride is added to aqueous silver nitrate to form a silver chloride precipitate plus aqueous potassium nitrate. And I'm not writing the AQs, right? Because we will assume that it's AQ if you don't write anything. Or at least I will. So our formula equation is KClAQ plus AgNO3AQ, and gives us AgCl solid and KNO3AQ. Right? And so you notice they're doing that partner swap, right? AgNO3, right? KNO3, K and NO3 get together, and our Ag and our Cl get together. Right? This guy's going to form a precipitate. Right? These guys are going to remain as ions in solution. Right? So our complete ionic equation shows where my ions are. So we're going to write that out as K plus and Cl minus and Ag plus and NO3 minus. And they're going to form AgCl solid and then K plus, right, because this guy is still aqueous and it's soluble, right? Anything in our column 1 is going to be soluble, so this is soluble. And all nitrates are soluble, so it's doubly soluble, and our nitrate. And if we look at it, right, we got our K plus is the same on both sides, so it's a spectator ion, and our nitrate is the same on both sides. So it is nitrate on the left and nitrate on the right. Those guys are our spectator ions. If we cancel those guys out, get rid of our Ks, get rid of our nitrates on both sides because they're the same, we end up with our net ionic equation. Right, our NIE, or NIE, right? Learn a Monty Python joke there. Or a net ionic equation, right? So it's going to be Cl minus plus Ag plus is going to give us AgCl solid. Okay. So let's gotcha check. Let's write out the correct formula equation, complete ionic equation, and net ionic equation for the reaction between cobalt 2 chloride and sodium hydroxide. We start with the 2 chloride. We're going to add in sodium hydroxide. We're going to let they're going to do the do-si-do and change partners. So we'll get cobalt hydroxide and sodium chloride. These are not balanced, so we got to balance this out. And notice we got 2 chlorines on the left. So we're going to balance this guy up by putting a 2 over here. When we do that, I've unbalanced the sodium, so I'm going to come back here. I'm going to balance this guy out. I've got 2 hydroxides on the left. I've got 2 hydroxides on the right. Everything is balanced. Looking at our solubility rules, all chlorides are soluble except for silver, gold, and lead. So, or silver, mercury, and lead. This is not one of those. I've got my sodium here. Anything that has sodium in it is going to be soluble. So this guy will be AQ. This guy over here is going to be cobalt hydroxide. Looking at the solubility chart, this guy is going to be a solid. All right, so writing this out, we're going to break these guys into their component ions at each step. Or we'll leave it as a solid if we need to leave it as a cobalt 2 plus, plus 2 Cl minus, plus 2 sodium pluses, plus 2 hydroxide, reacts to form cobalt hydroxide solid, and 2 sodium cations, and 2 chloride ions. All right, so we've got our molecular equation here. All right, down here we've got our total ionic equation, our TIE. Then when we want to do our net ionic equation, we're going to get rid of the spectators. Right, so if we look at the things that are the same on both sides, my chlorines are the same on both sides, so they're spectator ions. My sodiums are the same on both sides, those are spectator ions. We're going to get rid of those, and we end up with cobalt 2 plus aqueous. It's going to react with 2 hydroxides, aqueous, and it's going to form cobalt hydroxide solid as a precipitate.